My history of computers. How did we get here? By way of family history that I only peripherally observed, in the early 1960s my father flew around the western United States selling office machines for a Swedish company called Facit. I used Facit machines later, noisy machines that would sit on your desk, and with enough cranks of a wheel on the side, could multiply or add numbers. In 1967, as a 9-year-old, I saw the big IBM computers on display at their showroom in Stockholm, on Sveavägen across from the Wennergren Center. You could see them through the glass, from the street. The lights would be on at night. In 1968, I was back in Oakland, California. My mother let me play with the Friden desktop calculator she had at work, a big expensive machine that could do basic arithmetic. When I used it, it broke, and they had to call out a repair technician. In 1969, I took an electronics class from University of California Extension, during the summer break. This was all about vacuum tubes, and soldering, and how much it cost to punch metal. I wanted to build a computer, and the teacher, the late Nicholas Saba, introduced me to flip-flops. You could buy them at an electronics store for $2 unassembled, or $3.50 assembled. They were an electronic breadboard, the size of a small paperback, with 3 transistors and a light on top. I was broke, so I went for the $2 kind. Eventually I was able to get 4 of them in a row, working occasionally, and counting up from 0 to 15 in binary on a good day. In 1970, I took a programming class from University of California Extension during the summer break. This used the Bendix G15 at Oakland Technical High School. 2,000 words of main memory on a drum, 700 of which went to the operating system. Paper tape cartridges, one of them labeled Algal Compiler, although I never used that. Assembly language ruled. Assembly language was numeric, 52 1052, I'm making the numbers up, would load location 1052 into the accumulator, and so forth. You could do quite a bit with the machine, actually. The accumulator was a special track on the drum. I think it could do on the order of 1 instruction per revolution, or say 100 instructions per second at a guess. Vacuum tubes throughout the size of a closet. Input and output was on a console typewriter. It broke down fairly frequently, and was serviced by control data. My friends in the class would talk about the new IBM 370 series coming out. I was also taking a sailing class in Alameda, and the teacher was designing boats, I think, from a terminal in his small office connected to a time-shared 7090 or 7094. These were second-generation mainframes from IBM, about 10 years old at the time. I was invited to use an IBM 1130 in my mother's research building, on Piedmont Avenue in Oakland. Great stuff. A printer, 8K 16-bit words of memory, a card reader, removable disks, which cost $90 each. They had 100 of them. A staff of 3 programmers at a guess, 3 key punch operators, and a computer operator. I was told it cost $2,000 per month to rent the computer from IBM. Fortran was the language of the day. I did accounting for my paper route on it, and I wrote a casino simulation game for the console. In 1971 I was back in Sweden. A friend was interested in helping me build a computer. By the time the Texas Instruments 7400 series of small-scale integrated circuits were well known, you could get 4 2-input NAND gates on one chip, or even a 4-bit arithmetic operation chip with 24 gates, the 74181. I sort of abstractly understood what the chips did, and could figure out how you might do pieces of the CPU. I don't think I ever got to the point of figuring out how you would get a full stored program operation going, or how to lay it all out on boards. I also got to tour the IBM data center. By now it was in an enclosed room in Nacka, further out from town. They had a 7034 which seemed to be getting to end of life, and various pieces of IBM 360 equipment. I have photos of some of this on my Flickr site. In 1973 I was able to use the computer facilities of the Royal Institute of Technology in Stockholm, on the side of my regular gymnasium studies. They had an HP time-shared computer with noisy teletypes in the basement. Programming was in BASIC. You could save your programs on paper tape emitted by the teletype. They had access to an IBM 360 Model 75 which I migrated to in short order. There was a 360 Model 20 remote job entry system on campus. You punched up your cards, submitted them to the guy at the counter. A while later the cards and the printer output would be in one of the boxes. Big spenders could use a 110 baud terminal to something called Gothenburg University Time Sharing System, GUTS. Even bigger spenders could use a 300 baud terminal. You would be given an account with X kroner. I think they eventually gave me 3,000 kroner, and then you could use it any way you wanted on the computer system, or buying manuals. In 1974 I came back to San Francisco, and worked at Chase Econometrics in the financial district for the summer. This was a small office, my boss, his wife, and a programmer. We had terminals which linked up over acoustically coupled modems to a digital PDP-8 in the South Bay, from which they were connected to PDP-10 systems at Cybernetics near Chicago. We had free computer time. The time-sharing company wanted us on their systems. In late 1974 I was back in Stockholm with the 360 Model 75. I started using it at the main facility, QZ. This was jointly run by the Defense Research Agency and the universities. They had a digital PDP-10 as well. The computers were behind a floor-to-ceiling glass partition. Defense people approached it from the other side, I think. University and non-classified people came through a tunnel to the insecure area. There was an IBM 1401N1 printer, and an IBM 2260 terminal for seeing system status, that you could use yourself. There was also a communal work area, and some key punches. I tried using the very fancy 2250 graphics display unit. Hardly anyone did, and you got higher job priority for free when you did. It was slow going. I finally got a couple of lines to flicker on the display. Other graphics output was a direct-to-microfilm unit, followed by a microfilm printer, and a new Swedish invention, an inkjet printer. The main IBM Model 75 system had 1 MB of main core and 1 MB of slower extended core storage, made by Lockheed. They told me the system cost 20 million kroner, about $4 million at prevailing exchange rates, or about $15 to $20 million in 2011. That fits well with the prices I've seen for Model 75 processors, $1 million, and $1.50 per byte for main core memory, less for extended core. I would usually run jobs from card decks using the IBM Fortran G or H compilers in a 100K or 200K partition. At the end of each job it would say how much it cost, typically 15 or 20 crowns. In 1975 I came back to the San Francisco area. I tried to get time at the People's Computer Company, I think that was the name. They had some sort of small mainframe running in their office. I was interviewed, I think for general political leanings, and must have flunked. I got a job working as a contractor at NASA Ames Research Center. There were a multitude of computers to work with there, a digital PDP-8, a PDP-12, a graphics processor, the LDS2, hooked up to an Intel-840, a low-end Xerox Sigma 9, an HP system, and a PDP-11 Model 40. Eventually we acquired a PDP-11 Model 70 running an early version of Unix and the database system in Grace. On the side I was reading various small computer journals, including a letter from Bill Gates loudly complaining about why he was entitled to $400, I think, for every copy of his BASIC interpreter, and what he thought of people who made copies of it. There was a computer hobbyist meeting at a local bookstore on El Camino in Menlo Park, but I generally did not have time to go. I think Steve Jobs and Steve Wozniak did have time to make it there. To put things into perspective a bit, I don't think any of the NASA Ames computers were tightly networked together. We saw references to UCFmail, but I don't even think we had that. It was revolutionary when we introduced the PDP-11 Model 70 and Unix. Normal people in the office would email back and forth to each other, and you could enter documents and change them later. Woohoo! From a time of typed pages and punched cards, the idea that you could just change a document was huge. The PDP-11 Model 70 was upgraded with a floor-mounted 100 megabyte disk. The 11 Model 40, which was attached to a smaller Evans and Sutherland device known as the Picture System 2, had a pair of disk tapes as main storage. Spinning back and forth, it could take 20 minutes to do a link edit. I've looked these up since, and they seem to have about 384 kilobytes of random access space. That was plenty for a Fortran compiler, other tools, and a basic catalog file system. In 1976, Pascal was spreading fast. We had some versions of the P-code system, possibly from the University of California at San Diego, otherwise Minnesota, where if you could create code for each P-code, you could port the language system. We also licensed a copy of the PDP-11 compiler from the Oregon Museum of Science and Industry. The three gentlemen involved were role models to me. In a sense, they later formed Oregon Software. I could see the compiler business and it looked like free money. Also in 1976, I got a tour of the Intel factory, at the time producing the 8080. Tandem Computers was starting. We met with James Trebig, the founder, as we went looking for a computer, before settling on the PDP-11 Model 70. Amdahl, the plug-compatible mainframe maker, was well established and big in the Valley. In 1977, computers were just showing up in normal life. My boss passed away, and among his possessions was a chess-playing machine, as well as both an HP 65 and an HP 67 calculator. These calculators had small magnetic strips. You could store programs of up to around 200 steps. The HP 65 was around $800 when it came out, I think, about $3,000 or so in 2011. It came with a leather holster that attached to your belt. That way everyone would know you had an HP 65. As 1977 turned to 1978, I was working on assignment for National Advanced Systems. They were building IBM 370 plug-compatible mainframes. As I recall the explanation of the economics one night, IBM would sell a 370/Model 135 or 145 for around $695,000. NAS would sell one for much less, say $400,000, and the parts cost would be about $133,000. We were developing code using a time-sharing system on, I think, 370 Model 158 systems. One of our programmers rang up a $90,000 bill for time-sharing services in a single month, about $400,000 in 2011 dollars. In 1978 I left to join a compiler project for the secret new Intel 8086 chip. 1 megabyte of memory was supported by the architecture, 16-bit operations, multiple registers. This was to go into a telephone switch, to replace an earlier model that used assembly code on an 8080 or 8085. We developed the compiler on a PDP-11 running a digital operating system, later switched to an IBM 370 Model 155 in Florida, with a dozen or more terminals used by 50 or 60 programmers. Still in a glass-enclosed, raised floor, inside space. As an example of the second system effect, the first time they linked the new system together, written in a high-level language, it went from 64 kilobytes on an 8085 to 3 megabytes on an 8086, more than the architecture could support. Intel development in 1978 and 1979 was using their development boxes. We had to compete with IBM across the street for service technician time. That made more sense when they announced the IBM PC, developed across the street. In 1980 I moved back to the Bay Area. Digital PDP-11 computers had started to invade even the mainframe environment I left in Florida. We drove out to California. On the way I saw a Cray Model 1 at the National Center for Atmospheric Research. They said another Cray, which burned down when the night watchman turned off the overheating alarm, cost $7 million. The group I joined was trying to develop a 32-bit virtual memory microprocessor, the National Semiconductor 16032, and a workstation environment built around it. The central computer for 50 or 60 people was a digital VAX 11 Model 780, and generally there were 30 or so people online, with terminals at their desks. We had Berkeley Unix and spent a lot of time playing early video games such as ROG. UCF, mail existed and we could mail to people at other sites. Ethernet had been published. Our intended system was a bit similar to the Xerox Alto, a screen and a disk and a local network connection for each user. I believe the VAX 11 Model 780 system cost $200,000. In 1980 I took a Facit design class at Stanford. We used Ethernet-connected workstations, the above-mentioned Xerox Alto, and Ethernet-connected laser printers. In 1982 I left to form Green Hills Software, a compiler company. My boss, who was between me and the other Green Hills founder, left to become employee number 7 at a new startup at Stanford, Sun Microsystems. Both Sun and Green Hills had explosive growth. Many companies were switching over to networks of Ethernet-connected workstations, and trying to move their code base to microprocessors. This was 2 years before Cisco was founded in a Menlo Park living room, and a couple of years after Oracle was formed. Green Hills itself bought a Cisco router in 1989. At that time it was a cool piece of hardware for $5,000 or so to listen on the Ethernet networks in Santa Barbara and Waltham, and only send across those packets which were intended for the other system.